Welcome to Earth Changing Climate, a course with the Teaching Company. If you're new to my courses, welcome. If you've viewed or listened to my course, Modern Physics for Non-Scientists or Physics in Your Life, welcome back. This is a rather different course. We're looking at a much more contemporary scientific issue, and we'll plunge right in with the first lecture. The question it asks is Earth warming? And I hope in the course of this first lecture to answer that question, at least in the context of the last 150 years, and then in subsequent lectures we'll go on further. It happens to be a beautiful January day here in the Washington, D.C. area where the Teaching Company is located. It's sunny, it's climbing through the 40s and into the 50s. Just a nice day. Now that's a statement about the weather. I hope the weather's nice where you are, but having seen the weather reports this morning, I know there are parts of the United States that are digging out from blizzards. So weather varies, and weather varies a lot from day to day. And I want to make very clear distinction between weather and climate. This is a course about climate. It's not a course about the weather. It's not about predicting what tomorrow's weather will do. It's about long-term trends in the weather, how the weather changes over years and decades, not what happens from day to day. Now, having said that it's a beautiful day here in Washington, I'll also point out that it is running nationwide today some 20 degrees warmer than average for early January. And I'll also point out that the last few months in my home state of Vermont have been abnormally warm, remarkably warm. We've had only one significant snowfall. We haven't seen any temperatures below zero or even in the single numbers. Those are statements about climate. And they're statements about climate because they're comparing what's happening today, and not just today, but over, say, the last few weeks or months, with what has happened in the past over similar time intervals. So climate is about the long-term trends in the weather, the long-term trends in what's happening in the atmosphere, what's happening to temperature, what's happening to precipitation, and so on. Weather refers to the short-term, local, immediate events in the atmosphere. So I want to emphasize that distinction. This is a course about climate. Is climate changing? And particularly we're asking the question here today in this first lecture, is Earth warming? So let's plunge right in with a graph that looks at the Earth's average temperature, the global average temperature, some kind of representative temperature of the entire planet over roughly the last 150 years. And I'm going to pause here and give you a little aside on graphs. You know the statement that a picture is worth 1,000 words. Well, I think of a graph as being worth 1,000 numbers. And I'm going to show you lots and lots and lots of graphs in this course because there are lots and lots of numbers that summarize the state of climate. And the easiest way to see what those numbers are doing is to look at them graphically. So I have some obligations to you when I show you a graph. And by the way, those of you who are listening to this course in your cars or otherwise listening on audio, you have access to these graphs in your booklet, and I urge you to look at them at a time when it's safe for you to do so, not when you're cruising down the freeway. And I will try to describe as much as I can what these graphs show, so if you're in the audio audience, you'll get a sense of what's going on here. Not only are the graphs, by the way, in your booklet, but there's also a list of the sources of all the data that went into these graphs so that you can understand where they've come from. So my obligation is to tell you what the graph is showing, to tell you what the two axes, the horizontal and vertical axis of the graph, show you, and to tell you something about how uncertain we are about the information in the graph, because science is not 100% certain about anything. And before you say, well, wait a minute, what about science? Science isn't very useful then. Nothing else in life is certain, and science can be quite certain, and we can put numerical certainties and uncertainties on our information, and I will try to tell you when we look at graphs roughly how certain or uncertain we are. So let's go back to this graph of the average global temperature over a time span since 1860, roughly. And the first thing to notice is that the vertical axis here is in degrees Celsius. In the United States, we tend to use degrees Fahrenheit for temperature measurement. The rest of the world uses Celsius. A degree Celsius is exactly 1.8 degrees Fahrenheit. So if you want to make a very rough conversion, if you hear a temperature in Celsius or a temperature change in Celsius, you can roughly double it to get the temperature in Fahrenheit. There's also that 32-degree offset because water freezes at 32 degrees Fahrenheit, but at 0 degrees Celsius. So there's a little bit of complication in converting those. But I'll mostly be talking here in this course about temperature changes, and there a temperature change of 1 degree Celsius is equal to a change of 1.8 degrees Fahrenheit, or approximately 2 degrees Fahrenheit. Now, it's easier to measure deviations in temperature than to pin down the actual exact global temperature. And so this graph and a number of the other graphs I'm going to show you show not temperatures, but deviations in temperature from some average value. And in this particular case, the average value that the climatologists who prepare these graphs use is from the 1961 to 1990 average temperature. It doesn't matter what average we take, but once we take one, we're looking at deviations from that average. And the particular graph I'm showing you now shows deviations from that average, and I've done an area graph where I've filled in the area between the average temperature line and the line representing the actual temperature. And consequently, you'll see a number of areas where the graph is below that line and the graph is extending downward. Those are times when the temperature was below the 1960 to 1991 average, and you'll see regions where the temperature is clearly above that average, and you'll see some fluctuations where it's going back and forth either way. Why do we do these deviations rather than to try to get a global temperature? Well, as I'll describe later, these measurements come from thermometers all around the globe, different kinds of thermometers, different places, some in the ocean, some in land, some on mountains. It's much easier to talk about what changes are happening at a given station and incorporate those into a global average change in temperature than it is to talk about the actual temperature calculated from the temperatures at all these different spots. So we'll see very frequently temperatures expressed as deviations from some average. As I mentioned, these data come from thermometers, actual physical thermometers like you would use to measure temperatures, and I'll say a little bit more about how that's done later. I mentioned that I should talk about uncertainties in our information about these quantitative data. In the early part of this record, in the late 19th century and into the early 20th century, these temperatures are accurate by probably about 0.2 of a degree Celsius. That is, if you look at the graph and you say, well, the temperature was down by half a degree, it might have been down by only 0.3 degrees, or it might have been down by 0.7 degrees. In other words, it's plus or minus 0.2 degrees is roughly our uncertainty. By the middle of the 20th century and beyond, we're pretty sure that these temperatures are correct to within about 0.05 degrees Celsius, about 0.05 of a degree Celsius. And the reason for that improvement is an increase in the number of stations we have reporting temperatures from around the globe. So having understood this graph, let's take a look at what it shows. There's a lot of variation, first of all. The temperature fluctuates from year to year substantially. But there are several major sections in this graph, and they're worth looking at. First of all, from about 1860 into roughly the year 1900, the graph is roughly flat. Now, I say very roughly because there's a lot of natural variability in the climate, and you can see the temperatures fluctuating quite a bit. But overall, if you kind of drew a line representing the average trend here, the temperature has stayed roughly constant from about the mid-19th century, when this record starts, to about the beginning of the 20th century. Then there's a rise in the early 20th century, quite a pronounced, substantial rise in temperature. Then there's a leveling off in the mid-20th century, maybe even a slight decline. And then there's a rather steep rise that characterizes the final roughly 3 decades of the 20th century and that continues into the 21st century. So our question is, for this lecture, and for in fact the entire course, what causes this temperature variation? And how typical is it for Earth? Is this just what Earth naturally does, or is there something unusual here? That's a major topic of the course, but I want to give you right now just a very quick summary. So we think that the early part of the 150-year record, the variations there are caused largely by natural variations of 3 types. First of all, the climate system itself is a very complex thing, and it has internal oscillations. The El Nino phenomenon that you've probably heard of is an example of an internal oscillation in the climate system. It just happens naturally. The climate doesn't stay absolutely flat and steady. So that's some of the variation. Volcanic eruptions, of which there were a significantly large number in the early 19th century in particular, put dust into the atmosphere, and that exerts a cooling effect on climate. And we think volcanism has a significant role to play in the early part of this record. And there have been some significant, not substantial, but significant variations in the power output of the sun, and that's what, of course, supplies Earth with its energy, and so that causes some of the variations. But we're quite certain